Hello everyone. My name is Dmitry Vostokov, and I introduce today a pattern-oriented approach to software forensics. I decided to keep this presentation short and as simple as possible. If anything needs to be added or modified in the future, I'll create another version of it. Prerequisites for this presentation are very simple, and I suppose you all, like me, enjoy computer diagnostics, especially memory and log analysis. If you don't have an experience in computer forensics, or at least have only a familiarity with it, I hope this webinar outlines a unified big picture. If you have such an experience, this webinar proposes a pattern-oriented foundational approach. Just 1 second. Actually, a few slides are missing, so I just take a shortcut to freeze and copy the correct version of the slides. I think I deleted a few of them, so sorry about that. I'm just pausing my screen and then recopy the presentation and then restart. So just sorry about that. Okay, so we resume. So why we advocate a general pattern approach to traditional computer forensics? This is because we need a unified common language, and computer forensics is largely a part of computer diagnostics. As we would see later, computer forensic artifacts, structure and dynamics are the same as traditional diagnostic artifacts such as memory dumps, software logs, and network traces. Now we look at some definitions, and the first one is about forensic science or forensics. So you see that this is a discipline studying past, structure, and behavior. That's how we define it. It's probably the same as other definitions, or similar to them. There are many specialized forensics. Our concern is with digital computers. So we refine this definition a bit and add computers. And in computer forensics, our main concern is a software part, although we provide a direction for hardware later at the end of this presentation. And so we come to a preliminary definition of software forensics as a discipline studying past, structure, and behavior of software. On the other side, past structure and behavior can be seen and analyzed in various software execution artifacts, such as memory snapshots, dumps, traces and logs, source code, digital data, media. Now I take a detour and remind you a definition of software diagnostics we put forward in our previous webinars. As a discipline studying abnormal software structure and behavior in software execution artifacts, such as memory dumps, software network traces, and logs, using pattern-driven, systemic, and pattern-based analysis methodologies. What is considered abnormal is dependent upon specific requirements, functional, such as use cases, or non-functional, such as resource usage. Requirements can change. What was abnormal becomes normal, and vice versa. Next, we would like to remind you a definition of a software diagnostic pattern as a common recurrent identifiable problem together with a set of recommendations and possible solutions to apply in a specific context. Here, a problem is described by a set of signs or symptoms or simply by a set of various indicators. Please note that a problem may not even be reported, but can be hidden and can only be seen through health monitoring and analysis. We therefore derive a definition of a forensic pattern. Here, instead of a problem or a set of problem indicators or signs, we have just a set of indicators. And therefore, we come to a full definition of software forensics as a discipline studying past structure and behavior of software in execution artifacts using pattern-driven, systemic, and pattern-based analysis methodologies. So here we visualized a relationship between diagnostics and forensics. Just as a side note, diagnostics and its forensics part can be used for prognosis of software behavior, the so-called software prognostics. And as a consequence, we revise our definition of software diagnostics, where we replace abnormal with a set of indicators we call signs, and combine pattern-driven and pattern-based methodologies into pattern-oriented one. In the following slides, we would use software forensics, but keep in mind that it is a part of software diagnostics. So we see that software forensics is about patterns and pattern recognition. We say it is pattern-driven when we talk about a forensic process, and pattern-based when we talk about pattern lifecycle. We start with the pattern-driven part first. By software forensic analysis, patterns we consider a subset of software diagnostics patterns because they all have the same underlying sign structure and interpretation. In a pattern-driven analysis, we use pattern catalogs of pattern descriptions. Catalogs can be classified by abstraction, for example, as software forensic meta-patterns, which are patterns of software forensics itself, by the type of software artifacts, such as source code, media data, software traces and logs, memory dumps and network traces. And we can separate patterns by intention, such as malware, with unintentional patterns, the rest all grouped as victimware. Some catalogs become large and need partitioning. Memory analysis pattern catalog, for example, consists of more than 250 patterns. Software log analysis pattern catalog consists of almost 80 patterns at the time of this writing. For example, we can partition memory analysis patterns by execution space or problem type, such as crash, hang, spike, or leak. We can also partition them by structure and behavior. For example, we can create a smaller catalog for structural memory patterns. It actually exists. Another fruitful partition is by object types such as threads, processes, and modules. Ultimately, patterns are found on specific platforms. By pattern implementation, we mean differences in operating systems, product lines, media types, CPU and hardware architectures. Considering classification by artifact type, there are two main types: memory forensics and trace and log forensics. Although traces and logs are derived from memory and are memory-based, nevertheless, we advocate a different structural and behavioral analysis approach based on software narratology. The analysis of traces and logs uses narratology, the discipline that studies various narrative forms such as stories, novels, chronicles, dialogues. All these narratives have the same underlying unified structure, such as events ordered by time. For our purposes, a software trace or log is just a sequence of formatted messages sent from running software. For example, an event log or intercepted or formatted API requests, such as log from process monitor or network trace. They are usually arranged by time and can be considered as a software narrative story. We can also extend the notion of a temporal order and consider arbitrarily ordered memories, for example, memory ordered by memory, the so-called generalized narrative. Finally, this narrative approach can also be extended to real hardware, and we can reuse patterns from software trace analysis catalog. Ultimately, we can also talk about things as hardware, software devices, and their internetworking. The so-called Narratology of Things. And we project this into the future as narratology of robots. The analysis, or the so-called robotic narratology, the analysis of their communication between themselves and with humans is based on computer narratology, of course, and here robotic forensics is also a part. And at the end, a few words about logs, checklists, and patterns. You probably have seen the same diagram in previous seminars. This is an essential feature of pattern-driven software diagnostics and therefore software forensics. Pattern catalogs are rarely fixed. New patterns are constantly discerned or refined. This is the essence of pattern-based part of pattern orientation. From the discovery to pattern catalog, usage to usage, and also catalogs can be amended, refined, refactored. So at the end we provide links to memory dump analysis presentations, which are also applicable to memory forensics. Many debugging TV episodes also cover memory analysis, and tools such as WinDBG from debugging tools for Windows, and also complete crash and hand memory dump analysis will be updated this Monday. And skip the slide, some links for further reading about pattern-oriented software diagnostics, which can serve as a foundation for pattern-oriented forensics. Most of them are presentations with recordings, with transcripts published as books, and I also plan to upload all of them to YouTube by the end of this year, as well as here. Debugging TV is also on YouTube. And here are links related to software trace and log analysis. And most of it are applicable to trace and log forensics, of course. After this seminar, I post this presentation on Facebook, on LinkedIn, so you can download and follow these presentations. And a bit of advertisement, of course, just one slide. Software Diagnostic Services has also published a few courses related to Windows memory forensics. There are great discounts till the end of January 2014. Please have a look later on when we publish presentation link. So, what's next for this year? Although this year is about to end soon, we still have the last seminar on the 30th of December, this Monday. It will cover the theory behind the physical memory analysis, and it is an extension and correction of two previous seminars on complete memory dump analysis delivered in 2010 and in 2011. And this will also be published as a book in early 2014, hopefully in January or early February you would see. And so what's next for the next year? This is a selection of seminars planned. They will also be published as books. You may have already familiar with this partial list. To it, we only added a seminar about pattern-oriented software prognostics that covers prognosis of software structure and behavior based on diagnosis. And so this is all for this short presentation. It was just created to outline the theory behind software forensics, and I'm very interested in how to improve this introduction, so please send your comments and suggestions. If I can't answer your questions now, I then post it on Software Diagnostic Services website later. And so, thank you for attendance, and see you all this Monday. The presentation on Monday will be a bit more longer because we also do some hands-on physical memory dump analysis exercise. So we probably spend an hour on Monday. And this will be the last presentation for this year. In any case, if you are not able to visit to attend the last presentation on Monday, I wish you all Happy New Year in 2014. Thank you and bye-bye.